There we go. To record the session, because I keep forgetting. Anyway, so let's get started. We will. I'll just finish up a small item on American units versus metric units. There is one other country in the world that uses the American units. It's some podunk little country somewhere, I don't know, in the Pacific Ocean, a little island or something like that. Otherwise, it's just the USA. And I mean, I was trained as a physicist, and so I use the metric system all the time. And it is so much easier. For example, when I'm cutting down a big tree, I can get a quick estimate of its weight by just making, well, let's see, it's about 90 centimeters in diameter and looks to be about 30 meters high. And then I'll do some quick calculations in my head and say, this thing must weigh at least 1,000 kilograms. That's going to be a little hard to handle. So doing that in American units would be impossible. So
Canada uses the same system as well.
Oh, I thought Canada. Wait, no, distances in Canada are metric, right?
I think that's correct. All right, but I work in a engineering firm, and yeah, definitely imperial. At least the most of the time.
Yeah, that's
unless we get some stuff imported from Europe.
Well, in fact, that Canada gives us a beautiful example of the difficulties of transition from systems. Have any of you ever heard of the Gimli glider? This is okay, I'll tell you the story. Has nothing to do with our topic, but this came from the transition. Some years ago, they were making the transition to metric in aircraft refueling, and somebody had and a jet was getting ready to fly across Canada, and they the fuel load was specified in gallons. However, for some reason, somebody made a mistake, and the refueling person maybe misread the form or whatever, but it said so many thousand gallons, and he thought it said so many thousand liters. And so he filled it with that many liters, which is about 1/4 as much fuel as they needed. Okay, so they take off, they fly, they actually got about not quite halfway across the country when they just ran out of fuel. They're at 30,000 feet. They're over central Canada, which is pretty empty territory, and they got no fuel. And there is no airport anywhere, within hundreds of miles. And what they did, first, they flew that plane very carefully so that they were gliding. Second, one of them remembered that there was an old World War II military airport, not, only about 100 miles away. And so they said, let's go for that airport. And so they glided 100 miles. And by the way, as they approach this airport, they have one shot. If something goes wrong, they don't get to come around. They have to land correctly on the first try. There are little trees growing in the runway. They pulled it off. They landed safely. Nobody was hurt. They knocked down a lot of trees. They were so far out in the boonies that the people on the ground had to send buses, and it took hours for the buses to reach the place to retrieve the passengers. They had to disassemble the entire aircraft and truck it out. So that's what happens when you shift from one standard to another. Let me get these. Okay, maybe we should talk about the subject at hand today. So we're starting with, let's see, it's lesson 8. Is lesson 8 our first lesson, or are we doing 7A? Does anybody remember?
I think it's 8 and 9 today.
I think it's 7A.
Oh, 7A? Okay. Well, 7A is an easy lesson. It is, it's really just a presentation of various simulations I've done in the past. And the whole point of it is really just to demonstrate the, you know, how to express simple ideas mathematically. Now, in interactive storytelling, it's much more difficult, but a good way to start to get a feeling for how to use math to translate some simple idea into mathematical terms is with simulations like these. And there are a bunch of them. For many of them, you can actually look at the source code, although unfortunately the source code does not explain, you know, it presents the equations in rather clumsy form. The two good ones that I recommend are Balance of Power, because I wrote a book explaining everything. Now, did any of you try to go through that book? There is one really nasty problem, and that was with the Macintosh back then. We didn't have fast floating point arithmetic. We only had 16-point integer arithmetic. And so I had to play all sorts of silly games with word size and integer arithmetic. And that's a skill that was absolute. You really had to be good at that 40 years ago. But that became a completely obsolete skill just, you know, about 30 years ago. However, let me show you something here. Not only can I carry out 16-bit integer arithmetic with a great deal of resolution, I'm also quite good at, you know, making flint tools. I've really learned how to do that too. So you really, you know, that's welcome to life in the dark ages. Barry, you have a question or just, okay. So anyway, that makes it a little difficult to read, and I'd like to ask those of you who did struggle through the book, was the use of integer arithmetic a serious obstacle? If I had time to kill, which I don't, but if I did have time to kill, would it be really useful if I rewrote that in floating point arithmetic?
Well, for me, I think the biggest thing was really, I read it several years ago, but for me the biggest thing was the shift in the way of thinking, because I have a degree in computer science, so I have this tendency of thinking in terms of ifs and elses.
Yep.
And not as I always thought that you as a physicist, you tend to think more in terms of equations and numbers. Yep. Changing. And that was perhaps, I think, that the hardest thing for me.
Yep.
And also the most enlightening. It helped me to think in different ways. For me, at least, I think that the step from integer to floating point is relatively simple compared to the change from ifs and elses to arithmetic.
Okay. Well, in fact, one way of thinking about this is just talk about the word size. If then else stuff is 1-bit calculation. It's Boolean, and so it's 1 bit. Integer arithmetic was 16 bits. And with floating point, we typically use 32 bits. So we've just been expanding our word size. And now we're at the point where the word size is no longer a consideration. When I got started, we were using 8 bits. And doing calculations in 8 bits, there were a lot of problems. You really had to develop a feel for how to use 8-bit calculations. But I'll point out that in the development of human thinking, in the development of, you know, intellectualism, we started off in with 1-bit thinking. That is Aristotle and Aristotelian logic, and all of that is 1-bit thinking. It's Boolean, black and white. You know, if then else. That's the way Aristotle did it, and that was the way right up through Thomas Aquinas and scholasticism and so forth. And it was only the first people to start thinking in quantitative terms were the Oxford calculators around 1300, 1350, I think. And for example, Robert Grosseteste was one of them. By the way, I have an essay about him entitled Bobby Fathead, because in fact Grosseteste is French for large head, so I sort of renamed him. Anyway, this shift towards quantification was also actually the primary push. There were 2 pushes. One was the Italian merchants. They realized, you know, you can make more money if you calculate things, and there was this profound shift in the way the Italian merchants around just before the Renaissance, the way they did their business. Until then, they just sort of, you know, buy and sell, and they kept records of what they owed. But the first big step they learned from the Islamic merchants, which was keeping proper account books. And then the big trick was double entry accounting. This was one of the major leaps in human thinking, where they could actually keep track of precisely where they were at any given point. This also is what led to the development I suppose the refinement of arithmetic. Now, the Greeks could do arithmetic, and they did a lot of it if you read, what's his name, Ptolemy. But, I mean, they could do, well, trigonometry, in effect. But the Italian merchants realized that, you know, you got to be able to do arithmetic. And we think of arithmetic as trivial, but in fact, learning how to multiply and divide and so forth. And by the way, they were doing this with Roman numerals, which was really hard. But if you were a merchant, you sent your son to arithmetic school so he could do arithmetic. And then the next big change was what we call Arabic numerals, which are actually Hindu numerals, the digits 0 through 9. And the Italians realized, hey, that really works. It was Fibonacci who brought that idea from he lived, when he was young, he lived in Tunisia. And then he went back to Italy and he told everybody, hey, here's a better way of doing it. And it caught on because the guys who used it made more money. And so arithmetic developed really as a common thing in Italy around 1400. And that in turn was picked up by astrologers, because if you're going to calculate, you know, somebody's horoscope, you got to calculate where the planets are or were or will be. And that took lots and lots of arithmetic. And that's what really opened the doors to it. And really it was, well, it was Copernicus who started the thing, and then Kepler pushed it a bit further. But it was Galileo who kind of, you know, let's calculate everything. And so the big change was quantification. The idea of using numbers in the way you think really started becoming standard around 1600, just 400 years ago. This shift to quantitative thinking still hasn't happened with computer software. Think about that. Computer software is 400 years behind science. That's another example of why I say we don't understand computers yet. You really can't use a computer properly until you can think in quantitative terms, think in terms of numbers. So, not a happy thought, is it? Anyway, so the other good one that you might want to look at, which is a little hard, is Balance of the Planet, the new version. Well, there are two versions. The 1990 version, and then I did a version about 7-8 years ago. And I believe the source code for the first one is directly available. The second one, I'm not sure it's on my website, but I can put it up there if anybody wants it. But basically what's important about that is that it is a huge system of equations. It's not just, oh, look, here's how he expressed this idea in an equation. The value of balance of the planet is that they're like 80 equations and they all interconnect. And the way I handled that, that's a really difficult skill. But at some point you'll need to learn it, because with personalities and interactive storytelling, you cannot avoid having a system of equations, because, you know, process thinking and all of that. So let's see. And I got some questions by email and I want to address those. But right now, Scott asks, some of us have started projects attempting to take a step towards your interaction. Would you be willing to rank our attempts near the end of the course? I'm certainly willing to give you feedback on those. In fact, another fellow in the other course sent me some stuff that he had been experimenting with, and I still haven't responded, largely because I don't think it makes any sense, but I keep thinking maybe I need to look at it from a different angle here. So anyway.
Well, thank you.
Pardon? No, this was somebody else, somebody who's not in this course, I think. George, although he may have been working with somebody else. In any case, it was a card thing.
Yeah, George.
Okay.
We're all, there's about 3 or 4 of us working on projects.
Okay.
And one of them is a card version, but we're putting it in Unity and maybe on a tabletop simulator. We're playing around with a lot of different things. So.
Okay. Well, it was actually quite good that he sent that to the card thing to me, so I could look at it, because I think that the idea is fundamentally flawed, and I have refrained from telling him that because I keep thinking maybe there's something hidden here. I don't want to shut him down. Because
yeah, I think we want to prototype rather than creating the AI. We're just having another human play it and then figure out the AI afterwards. So
yeah, I agree.
It's a step, small step.
So anyway, I'm going to have to write up exactly what I perceive to be the flaw. I think it has to do with the way the human perceives the information he gets, but I'll get to that. Okay, so let's move on to lesson 8, where we really start getting into serious stuff here. I talk a great deal about the nature of models. You know, what a model. A lot of people don't understand, basically, everything is a model. For example, the word, let's see, here we go, calculator. The word calculator is a model. The word itself, that is, when I say calculator, you think of something. But remember, there are a million different kinds of calculators. And so you're thinking of a general concept. Now, yes, there is this particular instance of a model, of a calculator, but that's not the model. The model includes things that this doesn't have. And this has a lot of things that the model doesn't have. So a model is a generalization. It's a, you know, I think the word I like to use is characterization. It's a way of thinking about something, but it is necessarily incomplete. A model that is too complete, I mean, a model that describes this perfectly is useless because it works only for this one thing. And if I want to talk about this one thing, then I would talk about an HP 11C calculator. So I wouldn't use, you know, I have to specify the particular instance. The whole idea of a model that makes it useful is that it can apply to many different situations. And so you can have broader, and so models have degrees of specificity. For example, we can talk about, you know, rocks. And the word rock is a model for a hard object, but then we can get down to a little more specific, and we can say, well, we can talk about igneous rocks, or metamorphic rocks, or sedimentary rocks, and then we can break those down even further. And so we have these taxonomies. Every model is part of a taxonomy. So anyway, you need to think about models as many times people will say, oh, well, that's just a model. That's not reality. You can't specify reality. Reality, truth is infinite. You can never, ever specify anything perfectly. No matter how much time I take trying to specify this thing to you, I'll never get it perfectly. I would have to write thousands and thousands of pages to get pretty close. So you're never going to get there. And so you shouldn't, you know, don't worry about the fact that your model is incomplete. Most people try way too hard to get an accurate model. And the key idea here is that accuracy is as accuracy does. In other words, this is also called the operational definition of reality. You only need it to be accurate enough for whatever you're going to use it for. Truth is not something that just exists. It's something that you use. And so if you're going to make a personality model for an interactive story world, you don't need to cover every aspect of human personality. You only need to cover those aspects of human personality that apply, that will be used in your story world. The simplest example of this would be something about sex. You could have variables or attributes for, you know, how lustful a person is, and another one for how sexually attractive they are. But if this is a story world about 5-year-olds on a playground, you don't need that at all. So similarly, if this is a story world about seduction and so forth, you don't need variables about how good you are with crayons. That's irrelevant to it. So you start from the basic issues you're going to address in the story world. Your starting point is, what is this story world about? What aspect of human nature or the human condition do I want to talk about? And you don't say, I'm going to talk about everything. Boy, I'm going to have a story world about the entirety of human nature. It's going to be so accurate, so complete. You're going to fail if you try to do it that way. You really need to narrow it down. And this is central to the whole concept of art, because in art, to do it well, you got to strip away all of the extraneous stuff and really bore in on that one little truth that you really want to communicate. I mean, all great art is really very specific and involves a lot of stripping away of other stuff. You know, one of my favorite pieces of art is Michelangelo's Piet, and that is you know, that is really focused on the idea of maternal grief, and boy, it is all about that and nothing else. Another one of my favorites is Michelangelo's Libyan, come on, not Muse, Libyan Sibyl on the in the Sistine Chapel. I don't know, something about it is just very good, and it's really about the gracefulness of the human body. Anyway, so yeah, you got to strip away stuff, and so your starting point is the most precise definition of what your story world is going to communicate to your audience. I've got my audience. This is what I want to say, and try to have a very clear idea of that. Then you can start talking about your personality model, because you know what you need to have in the personality model. And so then you ask, all right, what personality traits directly participate in this aspect of human nature? And then once you define those, you can get rolling. I'll warn you though, the mistake everybody makes over and over, I have not seen anybody who doesn't make this mistake, is they throw in too many variables. They just have too much stuff, and then it gets confusing. I better respond to, oh dear, to some of these questions here though. No, wait. First, the questions that came in by email, because they were asked first. Let's see, from Barry. Let's see, here it is. What specifically is the difficulty a player would have in discerning dishonest behavior? Simply that there aren't enough vantage points from which to assess that the behavior was dishonest, and in any case, is this not a problem that can be solved given clear enough design? Dishonesty is easily measured through behavior. That is, if somebody lies to you, you know they're dishonest. However, that determination suffers from two problems. First is the most obvious is small number statistics. If they lie to you once, does that make them dishonest? How many lies do they have to tell before you think they're dishonest? Well, you can resolve that by simply saying, every time they tell a lie, I will increase my assessment of their dishonesty. That works, but how do you know it's really a lie? I mean, you got to have a database of truth, and this gets into some complexities. Now, there is one good thing you can do, and that is what I call the grapevine. Ever heard the song, I heard it through the grapevine? It's from the 60s, you're too young. Anyway, the grapevine is the chain of gossip as it travels through a group. And so if you really are going to trace dishonesty and lies, in fact, you can make a wonderful story world just about lying. And in fact, many years ago, I came up with an idea for a spy game based on lying that used this. What you need is a data structure. It's two data structures. Oh boy. I'm getting into stuff that's a little further down the line. I'm sorry, I better just leave this for now because there's some other data structures I have to explain before I can get into this. So I'll just leave you tantalized with the idea that there is a way to deal with lies, but it involves a bunch of other stuff that I'll have to bring up later. So, oh, and the other thing you'll need to keep track of is the significance of a lie, the importance of it, or as I call it, the import. A numeric value. That is, if somebody says, no, I didn't eat that cookie. Well, that's a little lie. But if somebody says, no, I didn't have sex with your wife, that has a lot more import. So you got to have a way of measuring the import, and there are ways to do that too. Why is it important to have traits be as separate as possible? It seems to me that many traits influence all of my decisions, so I'd like to have these characters whose actions are influenced by more than one value. Certainly not if two stats are literally always overlapping, but overlapping a fair amount seems fine. Is this just a way to reduce complexity? Okay, this is a very important point. I call it orthogonality. You want your personality traits to be orthogonal, that is, to be completely independent of each other. And the reason has to do with the actual process of writing the algorithms that control behavior. Here you are, you've set up your personality model and you got 20 different personality traits. Boy, I got a trait for everything. How much do they like chocolate as opposed to vanilla? You know, I got all of them in there. Okay, good for you. Now you're halfway through the process of building your story world and you're setting up algorithms for certain behaviors. And so here's a situation where Joe, let me just make up something. Joe looks at a painting and says, you know, that's a really stupid painting to Fred. And then your question is, and then the problem is, how is Fred going to react to that statement? Well, if you got a million or you've got a lot of personality traits, you'll say, well, I'm sure his appreciation for color is going to apply to this. But then there's also how sophisticated his artistic training is, and we'll need to put that in there. And then there's the question of how much he likes the artist, and we'll need to put that in. And if you've got a lot of overlapping traits, you end up fighting yourself over which traits to put in, and you end up writing algorithms with big, long equations to them. You end up writing something where, in effect, y equals ax plus by plus cz plus dt plus eu. And then later on, you're trying to balance that. You know, you get crazy results. You're actually running it. And Fred blows up with fury at Joe for saying that. And you say, hey, why'd you do that? And you got to go through all the numbers and dig it out and then say, oh, yeah, the coefficient for this variable was too large and I need to push that down. But then that screws up something else and it's hell. You do not want to get into these multivariate situations. The ideal would be to make everything linear, a single variable. That is, it's just y equals ax plus b. He reacts to this based exclusively on how much he likes that person. Well, it turns out that is generally too simplistic. In practice, you're going to end up with two variables. I feel that that's probably the best overall way to handle this. And in fact, I ended up developing an entire mathematical system based on the assumption that you're going to use 2 variables with well, actually a total of 3 variables, 2 primary and then a modifying one, which can easily be a constant. So, and I will show you that later on. And I strongly urge you, for now, stick with that. Keep it simple. Later on, when you're a genius and you can, in your head, you can have 6 variables interacting with different coefficients, and you're juggling 6 balls at once. Oh yeah, I can do this. Yeah, sure, go ahead then. But for now, it would be really good if you could just learn how to juggle 1 ball, or maybe 2. So start small. This is a very important point, and it's funny. I have pushed this on people for years, and people just, whoops, sorry. The dog wants in. There you go, dog. Her name is Molly, by the way. Let's see. Hello, Molly. It is just so tempting when you're working on an algorithm for something and you're saying, well, I've got just 3 personality traits, bad, good, false, honest, and submissive dominance. And you look at the situation, you say, well, none of them really apply very well here. I'll just cook up a quick 4th attribute to solve this one problem. And that runs away on you. That just causes bad trouble down the road. So be very, very careful. You are much better off stretching an attribute to apply to an odd situation than cooking up new attributes whenever you get into trouble. If the distinction between timid dominant doesn't include courageousness, then what attribute ought to be used to determine whether a person is more or less likely to do something potentially dangerous for a desired end? Well, the question really is, why do you have a story world that needs that attribute? Now, I mean, you could, some story worlds would demand it, but in such a world, would you also need the other 3? That it depends on your story world. And yeah, I can imagine plenty of story worlds that would require the basic 3 plus courage. But I would suggest that if you build a story world that requires a lot of personality attributes, then maybe you're biting off more than you can chew. Because again, this stuff is really hard to do. Remember, I spent, like 30 years working on it, and I still never got a good story world working right. And I'm a genius. So, anyway, this is hard stuff. Are you providing us with your preferred personality traits as an example, or do you think this is just generally the best way to do personalities? It seems to me the big part of the art of a game would be in determining which sorts of personality traits one wants to focus on, so each game ought to have a varied list of, as far as attributes. Yeah, I agree that I'm offering those 3 as a good basic general purpose starting point. I know those work fairly well. If you don't want to sweat personality model, start off using those. My guess is that after you've got some experience with those, you'll want to make your own changes. But do not create, in fact, here's the way I'll suggest it. For now, for your first attempt, use that personality model, and do not even consider changes to it until after you have written all the algorithms for your story world. there are two stages here. Stage one, create the model. Stage two, use the model. Apply it in many different places where you had to write a lot of different algorithms. And you had to balance them all against each other. Only after you've actually gone through that experience of applying a personality model, of using it, only then can you really appreciate what is required to design a good personality model. So although the one I'm offering, I know it has weaknesses, I know that it doesn't work in some cases, I think it's probably the best starting point, and it's flexible enough that it can be applied to a lot of different story worlds. So I urge you to take that simple approach, even though it will hold you back. Let's see. You might hate me for suggesting this, but your personality model would also make for a hell of an addition to the spatial violent games bubble. Yeah. Imagine if characters in a stealth game had opinions of each other that influence how they behave. For example, if a guard trusts you and you lie to them about how so-and-so is a really bad dude, they might look the other way while you do it. One guard might be a racist and not care while you're robbing the house of a family with a different skin color. That's extraordinarily simplistic, but you can imagine the possibilities blooming exponentially. Yes. Yes, you can, but you will run into difficulties. Did I give you the bit about critical mass in story world design? Probably not. No, I didn't. Story worlds are like A-bombs in that they have a critical mass. That is, an A-bomb can't work unless it's at least this big. The minimum size is called the critical mass. You cannot make an atomic firecracker or a nuclear roadside bomb. Can't be done. You can't make them small. There's a minimum size, and at that minimum size, it's very inefficient. As you get bigger and bigger, you get more and more efficiency. So if you really want to use that uranium well, you build a monster bomb with lots of uranium. And so the idea here is critical mass, and that phrase has been used in many cases to express the idea that there's a minimum size before something starts working well. And such is the case with interactive storytelling. There's a critical mass of verbs. I would guess that we're talking at least 100 verbs. I still can't find it. Have you ever seen, when you were a little kid, the My Little Golden Book of such and such? The little bitty books for little kids who are just learning how to read, and they're about this big, and they have a shiny heavy cardboard cover, and you open them up and big, 24-point type and lots of pictures and only 2 sentences on each page. I'm sure you saw those when you were a kid. Well, I found the Little Golden Book of the story My Little Mermaid. I remember the Disney movie from 20, 30 years ago. And I went through that book with my highlighter pen, and I highlighted each unique new verb. I didn't count the same kind of verb twice, if different variations on that verb. I counted unique verbs. I found 123 unique verbs in that story. Now consider, this is about the smallest story you can find that is a full story. And this is a very simple story. It's for 5-year-olds, and yet it has 123 verbs in it. I think that gives us an idea of the critical mass for storytelling. We're talking at least 100 verbs for a very simple story world. My guess is really you want to talk about 200 or 300 verbs as the critical mass. That's a hell of a lot of verbs. And for every one of those verbs, you're going to have different reactions. And for every one of those reactions, you've got to write algorithms defining how that reaction takes place. So you are talking hundreds upon hundreds of these algorithms that you have to write. You know, probably at least 1,000 of them. And until you've actually done that, you will not appreciate how difficult all of this really is. Max, you have a question?
Yeah, can you give an example of like 5 or 6 verbs, the kind of verbs you can use in a story world?
Well, the most common, or the verbs I recommend for a starting point, the easiest possible story world, is the gossip story world I built, which is based on statements of affinity. Basic idea, and by the way, you might want to actually look at the original gossip game from 1983 that was on the Atari. There are simulators now. You can download the Atari simulator and then play the, download the Atari gossip game and play it. It's a terribly cute game. It's really clean and simple because there's 6 players. I think it's 6 or maybe 8. And basically all you do is call somebody up. And when you do, you encounter one of the great technical achievements of 1983. They pick up the phone and say, "Hello?" That was cutting edge sound design in 1983. The guy who did that was really good. So anyway, and you call them and then you say, "I like that person this much," or "I dislike them that much." You have levels of like or dislike. And so you just talk to people and talk about how much you like or dislike other people. And then you also say, well, she doesn't like him at all, but she does like her a great deal. And this is what I call circumferential statements of affinity. Anyway, the whole idea is statements of affinity, how much people like or dislike each other. And that, I think, is one of the fundamental social interactions we have in society. And so that's a good basic starting point. In fact, perhaps, maybe something you should do as an exercise to get started is build your own gossip game. With your own, a basic game about statements of affinity, and see how you'll find it. It's kind of difficult, even though there are only, let's see, there are only 2 basic verbs. I like that person this much. And the other one is that person likes this person that much. Just two basic verbs and a number of objects on them. But even then it's messy. Barry, you have a question?
Yeah, so you brought up the critical mass of verbs as a refutation to the idea of putting like the social personality models into like more generic and like conventional popular game types, but I'm confused why you couldn't just have more verbs in those games.
Actually, that's not so much a theoretical problem as an audience problem.
Sure.
That is, if you try to mix a conventional shooter with interactive story world stuff, you're basically gonna displease everybody. The people who shoot.
Okay, but like I know plenty of people who'd be very interested in that. Like it's not like you're not gonna get a AAA audience. You're not gonna get 1 million people, but you could get a few hundred.
Well, yeah, and in fact, I think you should try that. And my guess is that you would, in fact, have some success with it. But the thing I always ask is, how many children does a game design induce? A really good game design, the real test is how many people copy it and extend it and make variations on it and so forth. And I'm not sure that such a design would trigger a lot of copycats.
That's probably true, yeah. It'd be a pretty like cult classic type thing.
Yeah. Yeah, but a cult classic would trigger copies, so.
Perhaps. All right, that makes sense.
Okay, let's see. Let me catch up on some of the mini questions here in chat. Here's a quote from your essay on personality models. Here's a big idea. Truth is infinite. Nothing you can say is ever completely true. Every statement you make is a simplification of the truth. In other words, everything we know about reality is a model. Completeness is not the ideal of communication. That honor goes to conciseness. Am I correct in saying that this means the way we communicate an idea or the medium we use, be it verbally on paper, canvas, etc., is equal or possibly even more important than the idea itself? Well, the idea is also finite. And in fact, in many cases, one of my English professors, when I was a student, once said, if you can't say it, you don't know it. And there is a lot of truth in that. Many times people will, you'll be arguing with somebody, say, and they'll get frustrated and say, well, I can't explain it, but I know I'm right. And in fact, they're lying. If you can't explain it, you don't know it. So the act of articulating is itself the final step in figuring out an idea. This was Aristotle's big discovery, that writing clarifies the process of thinking, that writing is sort of like a navigational tool for thinking. And in fact, a habit I developed very early, and I strongly urge on you, is something I call the design diary. Every day I would write just a short one-page diary entry saying, this is the problem I'm working on today, and I really don't know. I mean, I'd like to do it this way, but if I do it this way, then I'll have to do that. But I could do it that way, but that wouldn't be good enough because of this. And I just sketch out my thinking. That process of putting your ideas down on paper, of condensing them into actual words, will greatly sharpen your thinking. So write design diaries. I've got lots and lots of them on my website. They're actually very informative, because if you take the time to read through a design diary, and they are, I'm sorry to say, rather lengthy, what you'll see is that I zigzag all around. I make mistakes, and then I go back to other ideas. The design process is a difficult one, but by openly considering all these possibilities and putting them down on paper, I sort through some very complex issues and eventually converge on a solution. So, you might look at that. I would say the only perfect model of something is the thing itself, actually. Well, actually, then it's not a model, it's an instance. A model is meant to be, to apply to many different things, because an algorithm is meant to apply to many different things. I mean, if you're writing a story world with one character, then you don't need an algorithm. You simply say, Joe does this, then Joe does that, then Joe does this, then Joe does that. But as soon as you add a second character, then you got to write an algorithm that says, well, if this person has a really hot temper, they're going to do this. But if this person is very cool and doesn't lose his temper, then they'll do that. You need a model. So models apply to multiple things. Instances aren't models. Like the perfect model of a rock you showed us is the rock itself. Yes, so it's pointless to make a perfect model of something, I would say. There's no point in making a model of any individual item. The whole value of a model is the fact that it can be applied to many different things. Again, this is Aristotle. All rocks are hard. That applies to all rocks. And so I can say, this is a rock, therefore it is hard, the syllogism. On the other hand, I could say, this rock has the words written on it, Chris Crawford's rock. Well, fine, but then I couldn't say, this is a rock. I don't know what it has written on it. So it's the difference between the general and the particular. It's not a model if it's the thing itself. Yeah. The thing kind of describes itself in a way. We could say it's a bunch of molecules that represent this exact rock or something like that. I don't know. Okay, let's see. About the personality model. Do you think it's interesting to use a list of emotions and or moods that translate the way a character feels at a given moment? Obviously, your interactions with the character would affect this. Yes, moods are, I agree that there is a distinction to be made between personality traits and moods. For example, you could talk about how good, bad somebody is. This is a nice guy, this is a nasty guy, and so forth. But you can also talk about how angry a person is. And anger is a shorter term version. You could have the good guy who gets mad and yells at somebody. He acts in a nasty way, even though he's a good guy. But then 5 minutes later, he's not angry. Yes, there are moods, and in fact, I think do I talk about them in this? Oh no, I don't think I talk about them in this essay. Yes, I do have moods, and I know one of them is anger. Oh, yeah, one of the moods is sadness, joy. Another is calm, anger. And there was another one, I think I ended up throwing this out later, but this will surprise you, the polarity I use. Disgust, arousal. That may surprise you because many people will think, gee, what do disgust and arousal have to do with each other? But in fact, I have two arguments for that. One, I actually remember reading a psychological study about the hormones involved, and it turns out disgust and arousal are connected through the same hormone. But an even better example is from the movie All of Me from about 30 years ago. Great movie. Oh God, how do I explain this? In which I'll simply say there's a guy and a gal. The gal is inside the guy's mind, and the guy is getting really excited. This bad woman is trying to seduce him, and so she's, really working him over, and he's getting really aroused, and he really wants to jump in bed with her. But the gal inside his head doesn't want that to happen because she knows, she can see it's an evil plan. And the guy is just getting into bed with her when suddenly he stops and he goes into the bathroom to look into the mirror, because in the mirror he can sort of see the gal, and he says, "Dead kittens, what are you doing?" And it's a beautiful example of using disgust to counter arousal. Anyway. So yes, there are moods. And yeah, Max, you have a question?
Yeah, I would say that the difference between moods and like, for example, if a character is good or bad, it's like a moral thing where if you're angry at someone but for good reason, maybe you're gonna yell at the person but still be a good character. I don't know if it's...
Well, the way I handle it is to make moods automatically decline. That is, the way I have it is an event can trigger a mood. That is, your mood is normally 0. And a particular event can come along, like somebody says, "You're a stupid fathead." And your anger shoots way up, but then it will automatically decline exponentially. And in fact, I later put in a coefficient for that for temper, which says how high it shoots and also how quickly it goes away. So yeah, you can do that. I'll warn you, that does eat up a lot of cycles. Although nowadays we got more cycles than we can use. But turns out every time you go through the clock, you've got to relax everybody's moods. You could have two coefficients here. One for how intense the mood reaction is, and a different one for how quickly it relaxes. You're an artist. Lesson 8 says that the creation of the set of personality traits is governed by 3 ideals. Then you enumerate 2 of them, operational utility and orthogonality, followed by a section on slippery semantics, which doesn't sound like an ideal as the first. What's the 3rd ideal? I don't know. Please, I can't recall what I was thinking when I wrote that. Let's see, personality traits, operational utility, orthogonality. I would think actually that it would be more like conciseness or simplicity would be a 3rd ideal. I'll have to reread it to see. I'm sorry about that, Leander. Let's see, question for when you have time. In a story world set, for example, in a Mad Max style background, where the relations among people are mostly based on force for collecting resources, it would be useful to have a variable peaceful violent, or could it be overlapped by using a combination of, yes, it's always better to try to use a combination of 2 variables than to create a 3rd one. And in fact, peaceful violent does have elements of bad good in it, and elements of timid dominant. So I would definitely use those 2 because of the lack of orthogonality. Let's see, gut feeling might mean we don't yet have the, gut feeling might mean we don't yet have the vocabulary. So if you believe something is true, but you can't express it, then I would argue you haven't thought it through enough. You don't really need a big vocabulary. You can normally express almost any idea with a lot of simple words. But if you just cannot reduce it to words, then you need to spend more time. That's why writing it down, it's hard. You know, you think, well, what am I doing here? And you try to figure out how to express it. That is part of the act of thinking. So just referencing, yeah, if you can't say it, you don't know it. So, okay, we are out of time, and I just finished the question. Wait a minute, there was one other question somebody sent. Here we go, Ajmal. Having affection and trust variables makes sense, but I don't see why personality traits and perceived personality traits need to line up exactly. To me, it seems like it would be a more accurate model of relationships if characters judged other characters based on their own unique set of values as opposed to just how good they personally are. I think it would also allow for more interesting conflict and dialogue, and through playing a game, players would feel that they are getting to know characters better and understanding their personalities, like what one character values about other characters, what sort of behavior they really care about, instead of just figuring out where on the 2 sliding scales each character lies. I agree that it is not absolutely necessary that the perceived traits align directly with the personality traits. Well, no. Perceived traits definitely have to align because you're perceiving what they are. You could throw away perceived traits and have relationship traits. So you could have bad, good, but then a completely different variable, dislike, like. And that system would work. I actually fiddled around with it for a while and decided that I preferred the simplicity of using perceived relationships. I won't argue that the idea of having independent relationships is a bad idea. Again, there's so many things that we could to explore here, so many possibilities. You know, I spent 30 years exploring this stuff, and you can see how many questions remain. So yeah, if you want to throw away the idea of perceived traits, then you can just have relationship traits. But you might also want to consider the necessity of perceived relationship traits. This is what I call third degree or circumferential relationships. That is the idea of knowing that I express. What? You invited those two to the same party? Don't you know they hate each other? Occasionally, that information is of great value. So, last questions.
Just
Chris.
Just one. So you've spoken a lot about math in your game design, but what I figured out myself is that I know how to use a lot of math, but I don't understand it. Apart from like your lesson 7A, have you got any other recommendations, resources, or ideas on how to maybe grasp it a little bit better to understand it?
Practice, practice, practice. There's, you know, there are a lot of resources. You could spend an entire week digging through all those things I suggest. I mean, there's that whole book. But in the end, those serve only to point you in the right general direction. The only way you're going to get the feel for this is just do it. And I mean, that's what they say about writing. The only way to really learn how to write good fiction is to write a lot of fiction. And, you know, just practice, practice, practice. Recognize the fact that your first works are going to suck, you know, because you're beginning, you're just learning. So, you know, don't expect an awful lot. In fact, I would strongly urge you, do one that you know will be a loser. Just do a first one like that gossip thing. I know this is going to be a stupid little thing when it's done, but I want to at least get it rolling and see what's involved in putting the whole project together, because all these things interact in complicated ways, and you just got to see the whole picture by doing it. So, Barry, you have a question?
It seems to me like a lot of the most confusing and most difficult bits of working with a personality model like this, and I'm sure I'm underestimating because I'm sure there's way more confusing bits than I can think of, is going to be managing the perceived traits and especially the circumferential traits. It seems like that's going to be quite difficult.
Yep.
And so it seems to me like a really simple way to like it seems to me like we're taking a lot of steps at once by trying to do actual traits, perceived traits, and circumferential traits when no video game has even done actual traits yet.
Yep.
So it seems to me like, and I know I brought this up last week, but like if we were to do the idea of like simulating the social interactions between simpler mammals that don't really think of each other as individuals, but just think of each other as like or dislike, it seems like that would be it'd be much simpler to do like a wolf pack's like a wolf pack social game before trying to simulate humans, because humans have so much memory.
Yes, and certainly it would be interesting to do a wolf pack game. One of the nice things about that, I'll mention, is that you can cartoonize it. That is, think about movies where they're wolves and they have a little society and they talk to each other, and you know they act like humans. The nice thing about things like that is that you can give them as few traits as you want. You can make them very simple. And so really a cartoon type situation is certain. You definitely don't want to do real people. You know, you don't want to attempt to do War and Peace on your first try. So yes, starting off with cartoon-like characters would be a very a good way to start. And in fact, that the gossip thing I mentioned too has a real cartoon feel to it. So yeah, I mean, to have little balls rolling around talking to each other. I would, however, later on I'll get into this, but I think it is critical that you show faces, and I'll talk about the importance of faces in the future. But yeah. Okay. Oh, Paul?
My question was, you were saying that you should simplify variables to like 3 or 4 for people, but earlier you said that your balance of the planet game had 60 variables or equations. So isn't that a contradiction to say that? Shouldn't you have also tried to simplify that game to a minimum number of equations?
No, the difference here is personality model versus system. In an interactive story world, you will have like 1,000 equations. And in Balance of the Planet, I had about 80 equations. But the underlying factor in the personality model is just those 3 variables. Underlying factors in Balance of the Planet, oh, well, there were the instantial ones that were unique to each of them, but those were just constants. Basic, I don't remember. There were more than 3, but again, they were very narrowly defined, and this was a physical simulation, which is a lot easier because you can just say, you know, price equals demand divided by supply, much simpler equations. So, but again, look it over and you'll see what I mean. You know, it would be good if, I'm going to look into the idea, some idea of how to show you the Storytron, the C-Boot story world, or the Storytron technology. We'll build up to that, and then I'll make that, I'll allow you to download that. So let me ask though, how many of you have working Java interpreters on your machines? Oh, okay. So you can, okay, so you can do it because that was all written in Java. So, okay then, well, for next week then, we are doing, what, 9 and 10? Numbers and B-number math, yes. This,
Yay.
yeah, we're getting into details of numbers. This, it turns out the way you think about numbers is really important. I learned a lot about just plain old numbers while struggling with all these problems. So we'll be talking about numbers next week, and I will see you then.
Thanks, Chris.
Thank you, Chris.
Thanks, Chris.
Okay,
Always a
bye-bye.
pleasure.
Bye.